Reactions in aqueous solutions. As you know, more than 70% of our planet is water. Aqueous solutions are solutions dissolving water. For example, as you know, ionic compounds tend to separate in water. In this case, we have sodium chloride. Sodium, as is a metal, it separates as a cation, whereas chlorine, that is a non-metal, tends to separate as an anion. Spectator ions are ions that appear in both sides of the chemical equation, but it's not directly involved in the reaction. Usually what we get is a molecular equation, what we can see in the first row. In here we have silver nitrate and sodium chloride, both aqueous, and that yields to silver chloride as a solid and sodium nitrate in aqueous solution. The next is to separate the cations and the anions that are in aqueous solutions, as you can see in the second step. Finally, we cancel the spectator ions and we leave only the cations and anions and compounds that are left out. In this case is silver and chlorine, and that yields to silver chloride as a solid, and this is called the net ionic equation. A net ionic equation is then an equation for a reaction in a solution that shows only those particles that are directly involved in the chemical change. In here we can see silver back again and chlorine in the reactant side, and that yields in the product side to silver chloride. At the bottom we can see the spectator ions, in this case sodium and nitrate. There are three steps for solving these kind of aqueous solutions. The first one is to write the soluble ions, that is to separate the cations and anions that are in aqueous solutions. Second step is to eliminate like ions from both reactants and products, in this case nitrate and sodium. Finally, we write down the cations, anions, and compounds that were left out. Let's try this equation. In this equation we have potassium hydroxide, ammonium nitrate, both in aqueous solutions, and that yields as products potassium nitrate in aqueous solutions, ammonia as a solid, and water. So as we know, the first step is to separate cations and anions. This will lead us to the next reaction. Second step is to eliminate cations and anions that are in both sides of reactants and products, and is the potassium and the nitrate. Finally is to write down the net ionic equation. In this case will be hydroxide plus ammonium that yields to ammonia and water. In these reactions usually we see a solid forming in the product side, and this solid is called precipitate. In these reactions, for example, in the example that we can see now, is potassium iodide that is mixed with lead nitrate, both aqueous. This reaction produces lead iodide as a precipitate color yellow and is dissolved in a solution of water with potassium nitrate. It's the time for you to stop and test yourself the understanding of net ionic equations. Good luck!